Good evening. Good evening to all. We're going to start the session, and so we are actually 45 minutes behind the schedule, and looking into the limitation of the time, and I don't like to give the introduction at this moment, and I would like to invite the first speaker is Mrs. Alka Mishra, Sustainable Solution for Co-Processing of SPL Mixed Fines in Cement Plants. And I request the speakers to take 7 minutes, ready? And then after that there could be a bell for and then we should close the paper by 8 minutes. Go ahead, ma'am.
Okay. So, good evening to all. It's my pleasure to present the concept of co-processing of SPL mixed fines in cement plant in this prestigious conference. An overview of this SPL mixed fines, how it will promote to circular economy. It's a generation and consumption, particulars about this material, what the challenges we faced during the trial run, how to mitigate the challenges, and the conclusion of the trial run. So, a new pathway to sustainability when we are talking about any hazardous waste to be co-processed rather than allowing it to landfill or any of the disposal. So, aluminum industry, smelting industry produces generated a waste, SPL mixed fines, which a cement industry can consume or can co-process to convert it to the clinker as a wealth. So, as we all aware about it, that alumina in smelting industry used to extract or clean the pot, and they are generating two types of a waste. One is a cut one, which is rich in carbon, and it is being used in a steel plant or cement plant after the detoxification. But as so far the cut 2 is concerned, it is also coming, it is a part of 55% of the total SPL which is being extracted during the pot cleaning. It is not being used till date. So we in Dalmia family and our experts thought how to check the feasibility of this material to be co-processed rather than allowing this material to be landfill, because we always support and promote to the concept of the circular economy. So particular of this material, it is a mix of refractory and carbon, very less in the carbon, and it is coming from the alumina smelting industry. It is categorized as a hazardous waste, stream 11.2, schedule 1, as per the rule of hazardous and other waste management rule 2016. As per the rule, as per the standards, any of the hazardous waste which is not being utilized as a energy or as a resource recovery, it should be disposed in a safe disposal facility. Although it doesn't contain any energy value, this material, but it can be explored, it can be evaluated for some specific purpose, whatever the material is having the other material content. The generation of SPL mixed fines is a 16 to 18 kg per metric ton of the aluminium metal, and it is a 55% of the total SPL production. When we thought to check whether it is possible to co-process in the cement industry or not, the first step to check whether this material is meeting the requirement of the SOP given by the hazardous and other waste management rule, that is a leachable cyanide and soluble fluoride. When we found this, it is well within the limit, it has given us the confidence that yes, it can be co-processed. So we started evaluating whether the other material, other components can be evaluated, can be explored for the cement application or not. So we found it is good source of silica and alumina, and any of the limestone deposit which has a scarcity of the silica, and that it can be consumed there. Not only the material quality, during the trial run, we checked all the gaseous and dust emissions, and we found that the dust emission and gaseous emission at work zone and at the stake all well within the limit which is prescribed by the CPCB and the State Pollution Control Board. Now, when we are talking about any of the hazardous waste to be co-processed in the cement plant, challenges are quite natural. So the first failure, what we found during the trial run, we are unable to grind it in a raw mill. What we thought, this material is having good quality of the silica and alumina, so we can grind it in the raw mill because it doesn't contain energy value. But we failed to do so. And second thing, due to the wide variation in the silica and alumina, what we thought, we have to restrict the production. Although the trial run was very short, in the short period we have taken the trial run, but we have restricted the production due to the larger size of the material and the wide variation in its composition. Nothing is impossible, as all we are aware about it, and in Dalmia we have a lot of experts. So based on the discussion and everything, we took the trial run and we found that this is the mitigation policy if we can make a long run for this material. So first, as I told in the previous slide, this material has been not used till date. So all the generator is having the legacy waste. So the pre-processing of this material to segregate the contaminants, it is the first point to be mitigated and the size to be reduced as less than 10 mm. This will give the homogeneity of the material and we can use it very well. Second, the separate feeding system with controlled dosing at kill and
1 minute left.
One more minute.
Appropriate sampling during operation and additional requirement of additives to maintain clinker quality if we are having the sufficient silica in the limestone. And second thing, replacement of the existing hazardous waste to accommodate this hazardous waste to be co-processed in the clinkerization. So the trial run ended and we have concluded that 1% of the absorption of SPL mixed fines in the clinkerization, it is possible provided we have to fulfill the requirement and all the requirement of the Pollution Control Board and mitigate the challenges. Thank you so much.
Thank you, thank you. We move to the next paper is Right Approach for the Transport Design for Handling Alternative Fuels by Mr. Kapil Kukreja.
Yeah, good evening everyone. So I am going to discuss about the small component of material handling system, but this small component can stop the complete material handling system. And this small component is very much important when we are handling multiple types of fuel or multiple types of material. So this is few slides, which is the extract of the research, which is being done by it is joint research by NCCBM and BITS planning. So we have tried to develop a chute design which can handle multiple types of fuel, basically alternative fuel, where the density and other physical properties, moisture, these are variable. So we know cement industry, Indian cement industry has target of net zero carbon emission. Some people are targeting for 30, 50 and 70. And there are number of levers have been worked out for that. And one lever is the alternative fuel. And when we are talking about the alternative fuel, there are a number of options available. We have used tire, MSW, basically RDF, biomass, hazardous waste. And when we are handling this fuel, there are a number of challenges. It may be related to the product, environment, safety, operation, process, logistic. And in that particular presentation, I am going to target only operational issue, and this operational issue may be related to the material and may be related to the system design. So I am just focused on the system design. So we have carried out in 2019, when we started this research, we have carried out one survey in the Indian cement industry. We sent one questionnaire to 62 cement plant. At that time, those were using this alternative fuel. And out of that, 78% people, they have confirmed they are facing problem either in the transfer chute or feeding chute to the calciner. So that was the lead we got. Then we have taken one case study from one of the cement plant located in the Rajasthan. We found there is one chute, they were facing the problem. We went to the site, we visited to site, we collected properties, and they told us they are facing this problem, especially when they are handling the RDF, because you can see the variation in the property, moisture, particle size, then bulk density, it is varying throughout the year. We collected the data, we established the correlation between them. Then we found out angle of repose at site, angle of inclination at site, and we adopt the methodology because design of transfer chute, especially when you are handling the alternative fuel, you cannot go for the conventional approach that we are going for the other materials, like limestone, coal. Then you have to go for some analytical approach. So we adopted the simulation software, simulation tool. We use discrete element modeling method for that. There are some inputs, which some properties we have extracted from the literature, some property we have worked out through the calibration in the software, some property from the software library. Another challenge we faced, the shape of the particles, because we know in the RDF, the shape is the variable. So we have picked random shapes, irregular shapes, and worked out with the use of metaparticle feature in the software. Then we did the simulation, and we found where we are encountering the jamming issues. To resolve this jamming issue, we asked suggestion from the experts, from the cement industry, how they are approaching during the troubleshooting. So we got number of suggestions, design change, how we can play with the angle, how we can play with the cross-sectional area, width of the chute, then change in the inclination angle, then types of liner, the number of suggestions we have received. Then some people are suggested use the blaster and use the electric hammer. So we did not adopt these two features because blaster and electric hammer, that is for the case when the chute is jammed, but our target chute should not be jammed. We have modified existing chute because there was some constraint, the area was constrained. So whatever the best we can do, we developed two design, one with the angle of 65 degree, one with the angle of 70 degree. We changed the cross-sectional also. Then we simulated. In the first design, we found there is no much like improvement in the first design simulation. So we adopted design number 2, and we simulated. And within 9-second simulation, we found there is clearance of the jamming at that particular area. Then we established the condition of constant mass flow rate through the chute. And what we found, what the literature said, or what we have received during this simulation work, literature said the angle should be 55 degree to 70 degree. We found it should be minimum 70 degree. Then chute width, 3 times of the lump size, but we found at least 4.3 to 4.5. We are talking about the RDF, which is a more difficult material to handle, I know. Chute hood height at the material entrance. So we found minimum, instead of 0.5, it should be 0.6 of the belt width. And the major cross-sectional area, that depends on the cross-sectional area of the stream which is flowing through the chute. Then we found instead of 4 times, it should be at least 10 to 11 times. So I am going to the conclusion. Overlooking of bulk material properties, or especially the alternative fuel which you are targeting to handle with this system, you should know the input properties of that particular material when you are designing the chute to avoid future troubleshooting. Then we found DEM is the right approach to go forward. There are many literature available for the DEM, but this is the first paper, first simulation which we have done for the RDF. That is the first its own type. And these are the design parameter, recommended parameter, which I have shared. And one thing, instead of SS liner, which we found at that time the most common liners in the cement industry for alternative fuel handling, we propose polymer liners, basically UHMWP liners. We have published this literature also in one international journal. It is available. And with the line of to be the best, you must be able to handle the worst. It is well applicable for the transfer chute. The design should be best if it can handle the worst condition. With that, thank you very much.
Thank you, Mr. Kapil. I think excellent presentation. I think useful for the entire industry. Move to the third paper, Quest of Green Fuel at Kadapa Cement Works, Dalmia Cement. Mr. Netaji Rao is going to make the presentation. Good evening to respected chairman and co-chairman and NCB representative, all dignitaries. We are producing cement progressively and with greenery alternatives to build a nation. And Dalmia Cement have a business philosophy of clean and green is a profitable and sustainable to create a positive environmental and social impact. And we have started this green fuel that's we are calling as alternative fuels. Journey started in 2015. And we installed liquid AFR feeding system in 2018, and we installed solid fuel feeding system in 2021. Till that time, our TSR is single digit. And company profile is Dalmia Cement having 8 decades of legacy and 4th largest company. And Dalmia Cement has a committed carbon negative by 2040 by my group CEO and MD Mahendra Singhi at this summit at New York. And unit profile is Kadapa. This plant is at AP Rayalaseema, and we have a cement capacity of 2.5 million metric tons. We have a WHRS 12 megawatts and solar is 16 megawatts. And we have a products of OPC, PPC and SRPC. And we are catering the cement at 4 states in South India. And our ambition is 40% TSR and expected co-processing 1 lakh ton in FY23. We have massive bamboo plantation in 35 acres out of 50 acres. And our vision and mission, and it will be visible in my next slides. And national scenario for waste availability, approximately by 2025, one is 14 million metric tons of RDF, and hazardous waste, biomass, and tire waste. If we can use aware cement industry, they can achieve 25% TSR by 2025. And waste management, some of the Indian perspective from the CA study, and the collection of efficiency, 80% we have, and in that treatment efficiency we have 75%, and this for pre-processing platforms is we have at 80% only, and recoverability only 20%, and by 2025 this RDF generation will be 48% with CV of 3000 kilocalorie per kg. And to maximize the green fuel utilization to increase the TSR, we have taken initiatives. We have installed a liquid fuel storage and firing system, and we have 3 shedders and belt feeders and belt conveyors. And apart of that, we are going to execution on this RDF, that is at vendor place. We are paying 300 rupees per ton for separation and the straw mill purpose. And we have gas bypass system. And share in co-processing with payers, this Dalmia Cement have almost 5% in Indian cement. If you can say that co-processing volume around 14% of total volume. We have achieved TSR in FY22 15.5%, and FY23 as of November we are at 26%. This is the AFR process. When material is came to site, we are unloading and storing, and after that pre-processing with
shredding with whatever QC has decided that ratio to meet the CV and ash content, and after that it will go to the pre-calciner. And in the similar way we have liquid feeding system also. This is the planning of recipe procurement process. Before that, sample collection from waste generator and suitability checking. Once it is suitable, then it will go to the procurement process. This is the flow chart and compliance part and SEM, storage, and in continue that storage as per recipe. To achieve the 40% TSR, we need 600 tons per day solid feeding system as well as 100 tons of liquid feeding system. To sustain that, we need minimum 7 days stock at site. For that, 7,000 unshredded material will be, we have a capacity of storage. And after shedding, RDF and plastic are mixed properly as decided by QC requirement to meet the NCB and moisture and ash. And we have storage for hazardous waste and compliance of PCB rules and drainage system and sprinkler and water system we have. And we have a liquid storage tanks are installed for pre-processing. Feeding strategy. Based on CV and based on TSR target and CV and other feeding system will be arranged as per estimated. Based on this feed rate requirement and suitability size will be, we have a feeding equipment are installed and upgraded. Existing feeding system, we have a capacity of 25 tons. The same has been upgraded to 40 TPH to considering the 40% TSR. Presently, we have 4 storage tanks, which is the suitable for, we can feed it to 5 kL per hour. This is a blending for maximum TSR, consistent quality and alternative fuel is very much essential. For that, any deviation in CV or ash or moisture, any chloride, it will disturb the kiln as well as the poor quality of clinker. And different types of alternative fuels we are having, and based on that pre-decided and whatever the ratio we are fixed, based on that we will check before feeding the system as per QC department. And legal compliance, we are through everything with government bodies and APCB and CPCB and hazardous waste rules. And these are some of the awards we are received in CAA South Region Best Solid Waste Management in FY21 and first prize in Solid Waste Management FY22. And Indian Achievers Award is received by Unit Head. And this is the way forward. Target of carbon negative by 2040 and green fuel processing system to enhancement of 25 to 60 TPH. And we want to reduce the green fuel moisture and ash content. And we have to achieve the 40% TSR. Thank you.
Thank you, Mr. Netaji. I think you have come out with your visions of the plant to become a net zero and 40% TSR. So we move to the next presentation is experience of in co-processing of hazardous liquid waste in cement kilns at JK Lakshmi Cement, and Mr. Pankaj Tiwari is going to make presentation.
Good evening. My name is Pankaj Tiwari. I am representing here JK Lakshmi Cement Shiro unit. JKLC is the part of JK organization. Our other companies are JK Tire, JK Paper, JK Fenner, Umang Dairies. We have 3 kilns and their production capacity is 15,000 tons per day. Now, what is co-processing? Co-processing is the use of waste as a product or energy in energy-intensive industries such as cement, glass, steel, etc. Co-processing helps in circular economy, which reveals that nothing is waste. And the waste of one industry is a resource of or product for the other industry. Co-processing is the highest in hierarchy of waste disposal. The co-processing helps to conserve natural resources and reduce carbon footprint. At JKLC, we are contributing towards circular economy by utilizing various types of waste, such as pet coke from refinery, TPP fly ash, etc. At JKLC, we are using three types of wastage. First one is agriculture wastage, supplied by local vendors in solid form. Second one is non-hazardous waste, supplied by municipalities and our own thermal power plant in solid form. And hazardous waste supplied by industry in both solid as well as liquid form. These are the types which we are using it. And in agriculture waste, we are using mung husk, mechanical husk, rice straw, exhausted biomass, jolly flora. In non-hazardous category, we are using own TPP fly ash, plastic waste, de-oil cake, FMCG industry expired product. And in hazardous category, we are using solid mixed waste, TDI tar, distillation residue, paint sludge, and etc. Currently, we are associated with 61 industry and using more than 20 types of wastes. This is the process of utilizing hazardous waste. To identify the first step is to identify the waste generator / industry, take waste detail from the generator, sample testing, and check the feasibility of wastage. To apply with RSVB hazardous cell for authorization as per the category of waste. Site inspection of RPCV regional office to see the compliances of waste co-processing as per the hazards. Authorization grant upon successful inspection to their satisfaction, MOA with generator and third party, and purchase order. To the tech trial of alternate fuel in kill and optimize raw mix and fuel ratio accordingly. There are various challenges in utilizing alternate fuel like high moisture, foreign material, high ash, chloride, and sulfur. RPCB give a passbook for each type of wastage, and the same is to be maintained in SAP. To give a certificate of co-processing to the generator, that is the material has to be co-processed. 7 manifests come along with the hazardous waste vehicle, and 1 copy of the manifest is kept with us, and 1 has to be deposited to the Rajasthan Pollution Control Board. Apart from all this, we have to safety handle this waste as per hazardous waste management rule. Now, these are the methodology by J.K. Lakshmi Cement for co-processing of waste. Adequate amount of waste stored in the yard and decided to feed at the particular ratio. Prior permeability of fuel mix with kiln feed to assess the evaluation prior operation condition of pyroprocessing. Study of process parameter to evaluate the impact of waste on pyroprocess. Conduct quality tests as far as compressive strength and water absorption. These are the quality parameters which are regularly we have monitored. But apart from that, we are maintaining chloride less than 2%. These are the liquid AFR ratio statics. In 2019-20, we are at 1.5% of the total fuel. At 21-22, we reached to 2.5, and during this financial year, we are at 7%. These are the challenges, just like foreign material, failure of seal of the centrifugal pump, kiln stability, variation in the viscosity of the liquid. We have installed filtration system for removal of foreign particles, install AODD pump, proper atomization of the liquid with a flow control system, mixing inside the tanker throughout the return line. These are our future aspiration. At present, our TSR is 4.6%, and we are aiming for 30% by the end of 2030. And for the same, we are revamping the existing biomass system in Kiln 2 and Kiln 3 with the installation of double-stage shredder, extractor, double flap shed, and firefighting equipment. And second one is installation of solid feeding system in Kiln 1. At present, there are no solid feeding system in our line 1. With the installation of shredder, extractor, conveying belt, double flap, shed, and firefighting. Thank you.
Thank you. Thank you, Mr. Pankaj. Now we'll move to the next presentation is increased usage of alternative fuel by upgradation of the full-fledged feeding system. And this presentation is by Dalmia Bharat. Your good name, please?
Saravanan.
Saravanan, okay. Go ahead.
Good evening to one and all present over here. and I respected our panel judge and chairman and NCBM representative. My name is Saravanan from Dalmia Cement Arilur unit. I am going to present the increase the usage of alternative fuel by upgradation of our full-fledged AFR system. This is our group profile. Our Dalmia Cement founded in 1935 with a pan-India presence, 14 plants in 9 states, with a capacity of 35 million ton per annum. We are the 4th largest cement manufacturer in India. We are only the cement plant manufacturing a variety of special cement like oil well, ash strips, and railway sleeper grade cement. Coming to our plant profile, our Arilur plant established in 2010 with the world-class manufacturing facilities with power-saving equipment. Our installed clinker capacity is 2 million ton per annum and cement 3 million ton per annum. And we have the own captive power plant, which is capacity around 27 megawatt, and solar power plant 11 megawatt. We are manufacturing 2 kinds of cements. One is Portland Pozzolana cement and ordinary Portland cement. The trigger to take this project is mainly that CO2 intensity. For that, we have to focus is needed in 2 key areas. One is clinker to cement ratio and deploying innovative technology like carbon capturing and storage and usage of alternative fuels and raw materials. By doing this, we have to illegal waste dumping can be avoided. Because of that, we can avoid our soil contamination and groundwater contamination and contributing to the Swachh Bharat missions. Our Dalmia Cement follows the business philosophy of clean and green is profitable and sustainable, made us to our unit, not only our unit, it's across our Dalmia unit, which is giving the motivate to increase the full scale of alternative full-fledged we are going to implement it in our plant. Coming to the background, we have started our co-processing journey with a 3% through the manual feeding system with a single winches system. Then thereafter we have upgraded multi-feeding system and additional winches system. Thereby we could able to increase our TSR up to 10%. It is a manual. Because of that, we have faced a lot of problems. That is this ICO formation due to fluctuation in feeding and more fluctuation due to feeding uneven size and more manpower intervention which leads to the near misses and sometimes incident. This and frequent jamming of discharge chute. These all the problems is aggravated to increase the plant reliability go down and which leads to the high heat consumption and high power consumption. Then we had the good brainstorming session with the top management level and we come to a good solution for adopting a full-fledged AFR system with the 43 crores investment. So this full-fledged AFR system, which is comprising two areas. One is a pre-processing system and a co-processing system. So pre-processing system, it consists of 2 shredders, which is helping to reduce the AFR size. And we have the separator. It is helping to remove the separation of the foreign material like scrap and MS plate. And we have the screening system. It is done by the EcoStar screen, which is helping to the separation of our size reduction of the bigger size. It is going to again recrushing the shredder, and fine metal it is going to our stocking yard. This is a pre-processing layout. Coming to co-processing system, so whatever after setting the material, we have to mix in the homogeneous to feed the good recipe, like all the materials is uniform. Then it is being transferred by the belt conveyor, which is having the metal separator. It is separating the metal scrap. Then it is being going to the before going to the calciner, we have the proper control double valve system, which is helping to reduce the false air entry and avoid the backfire. This is our co-processing layout. So this is a greenfield utilization trend. When we are increasing the TSR rate from FY20, we have totally 15,926 quantity of waste we have utilized. But now we are sitting with 55,200 metric ton waste. It is 3 times of the earlier one. And coming to TSR, we are increased from 6.2% to 16.62%. It is by 2 years we have increased 10%. Thereby we can able to reduce the CO2 emission 83,800 tons of CO2 we have reduced. So this is the impact and the quality of the production. As you know that it is increase the AFR which is affecting the our clinker C3A. So that accordingly we have to slightly modify our LSF. So thereby we are maintaining our C3S level always in the desired clinker quality. And we have the clear-cut mitigation plan to overcome the further increasing the AFR. This one is a high moisture in the MSW, which is increasing our preheater volume. So that we are planning to upgrade our preheater fan with a higher volume. And the reduction from moisture we are doing in the sun drying. And coming to the high ash, we have the clear-cut mitigation. We have to set up the double shading system. Thereby, we are reduced some extent of ash we have to come down. And we are planning to install the trammel screen. So main part is a high chlorine in the all plastic, which is leads to increase our chlorine content in the clinker. So that we are planning to install the chlorine pipe system to mitigate and control the chlorine in the clinker. So coming to the benefits of environmental benefit, they reduce the CO2 emission and usage of municipal solid waste, which is helping to avoid the landfilling and reduce the usage of non-renewable fossil fuels and well-being people by helping them to become a disease-free. Coming to the social environmental benefit, increase the TSR from 6 to 16%. We can use fuel consumption reduced by 3,000 metric ton per annum for increasing 1% of TSR. And because of the increasing the TSR, we have the direct employment around 45 main days per day, and more than 150 members indirect employment is with our system. Completely we are avoiding the land filling, thereby this land contamination also can be avoided. So this final conclusion, co-processing of waste is in the kiln is the good solution for disposal of waste. So we have the huge potential to reduce the CO2 emission. Thereby our whole world is converting from grey to green. Thank you for giving opportunity for presenting our carbon towards CO2 reduction. Thank you.
Thank you. Thank you, Mr. Sharunan. Now we move to the next presentation by Mr. Pankaj Kumar from My Home Industries, and he's going to present on the use of pharmaceutical waste as an alternative fuel and initiative to turn the waste into wealth.
Very good evening to all. Myself Pankaj Kumar from My Home Cement, and presenting my paper, Use of Pharmaceutical Liquid Waste as an Alternate Fuels. This is the generic view of my plant, MCW, where the 3 units are there, and total capacity of my plant is the 3.5 million ton per annum of capacity of the clinker and 3.9 million ton per ton of cement. We have the 75 megawatt power plant is there, and we have also the 12.5 megawatt of WHR system and 8 meter cube per hour AFL feeding system is there. This is the overview of My Home Industries Private Limited. My Home is the leading business conglomerate of the My Home Group. Other core business of the groups are construction, real estate, power, transport, power consultancies, and educations. We have the 2 integrated plants, one at Suryapet district, Telangana, and one at Kurnool district. This is the total. We have the 2 integrated plant and the 2 grinding units there. Total plant capacity is the 10.2 million ton per annum. We have the ISO-based company. We have MCW received the CIA Go Green Rating Awards. We have produced all the range, OPC 43, 53, and PPC SG+, under the name of the Maha Cement. We have the strong network of the 5,000 dealers spread across the South India, Eastern India, and the Maharashtra. As I said, this is the total capacity of my plant. With that complete technology updated plant is there. Now come on the main topic, why AFR is needed. Because energy resources are limited, energy demands keep increasing, energy prices are continuously going up. MCW units utilize liquid pharma waste as alternative fuels in the kiln to reduce fossil fuels with an aim to avoid the environmental pollution, reduce the greenhouse gas emission, and conserve the fossil fuels and the natural resources. We have installed the solid fuel firing station. Silent feature of the complete plant is we have the 2 tanks of 100 KL capacity, and this plant is designed and supplied by the FLS Denmark with the cost of the 12 crores rupees. We have all the facilities comply with the safety and environmental standards as per the Central Pollution Control Boards. We have the liquid solvent pumping station, loading pump station, solvent feed pumps, and the multi-fuel station. The total capacity of the 8-meter cube of the solvent feeding pump to all the units. We have the safety system at the alternate fuels stations. We have the temperature sensor, arrange the 2 storage tank to monitor surface temperature. Whenever the tank surface temperature increases, the water sprinkler starts automatically. We have the foam type fire hydrant systems. We have the nitrogen blanketing system for the safety protection. We have the critical safety features at AF station. The static current distinguished pads we have installed at the outside of the AFL station, and we have kept another system is to keep the other electronic equipments outside the tanks. We have installed the Duotrust Max to absorb all the bad odors and create the good working atmosphere in the surrounding areas. Initially, we have faced a lot of challenges, just like viscosity, caloric value problem is there, chloride problem is there, jamming at the filters is there. So with that brainstorming with the team and with the help of the OEM, also we have come out, overcome with all the problems, and now there is no problem as such is there. We have also installed the scrubber system, dry scrubber system and the wet scrubber system to trap all the VOCs to create the working atmosphere healthy. We have the AFL environmental full-fledged lab is also there. We have made the efforts. What are the benefits by using the AFR? In the 21-22, we have consumed more than 27,000 metric ton of liquid AFL systems. By this 27,000 metric ton, we are able to reduce the CO2 in more than 10,000 ton. We have achieved the TSR of the 3.97 in 21-22, but in this financial, we are at the level of the 5%. What are the intangible benefits? No waste is generated that requires subsequent process, conservation of fossil fuels, and MCW helps more than 8 pharmaceutical companies to manage their waste in a sustainable manner. The direct employment generated due to this initiative is about 50 numbers and help to provide indirect employment to 60 numbers. Way forward. Our target is to achieve the 7.5% TSR with the existing system, and we are planning to install the solid AFR system to achieve the 20% TSR. As I said, at my location, we have the 3 units is there with the capacity of the 3.95 million ton per annum, and the brownfield project of 10,000 TPD are also running there. So our target is to achieve the TSR, 20% TSR. With the increase of the TSR percentage, MCW could achieve the sustainable growth in the reduction of CO2 emission and coal consumption to conserve natural resources. What everybody is seeing in this picture are the waste, but we are seeing the values in the wastes. Though the sustainable journey of the MCW continue with the higher strides, adding value to environment and sustainability. Thank you.
Thank you, Mr. Pankaj. So we move to the very interesting presentation, which is refuse-derived fuel co-processing in kiln, main burner in a cement plant case study.
Good evening, my friends. This is an interesting topic.
Mr. KPK Reddy.
Yes, sir.
Yeah, thank you.
Good evening, my friends. This will be an interesting topic to you all about we are moving towards the net zero emissions. As Indian cement industry is mostly probably concentrating on fuel injection points at mostly on the calciners and as well as in kiln raisers only. But however, if you have to go for more forward to net zero emissions, we have to concentrate on mostly on the kiln main burner also. Right. I would like to present one of the case study about a detailed project which we have carried out. Yeah, this is one of the plant having a capacity of around 1450 TPD plant, and as well as the specific heat consumption is around 960 kilocalorie per kg clinker, and it's having a suspension preheater kiln. And of course, they want to have a 25% reduction through fuel through RDF, and they are having a present coal mix fuel. They are having a CV of around 5,600. This is about the plant process operations. They're having a preheater of around 1.8 Nm³ per kg clinker, and kiln feed to clinker factor is around 1.48. And they're having a cooler. The cooler is first stage generation cooler, and as well as they don't have any kiln ceilings and outlet seals. This is about the volatile components which we have analyzed at their laboratory. We got this analysis about SO3 and chlorine. We found that SO3 in hot mill is around 1.2% to 1, which is, however, within the normal limits, and as well as the chlorine limit, if you see, it is around 0.11. However, it is in normal limits, but however, this sulfur to alkali ratio, it is around 2.01. Which is compared to normal operations of 0.8 to 1.2. They're having low alkalis in this plant. And these are the RDF characteristics which they propose to carry out in their plant. If you see the RDF which they are having mostly of chloride, maximum of 0.7, and as well as in footwear around 0.55. And CV, if you see the average CV, they are getting around 5,000 kilocalories per kg of RDF. And this is about, we have constrained about operating at 10% TSR and 25% TSR. We have calculated with respect to the, volatile operations about 10% TSR and 25% TSR. As we all know, generally where we inject the alternative fuels in the calciner and the main burner. Of course, this plant is having suspension preheater, so the rule outs are about the calciner part. However, they have a kiln riser, but the residence time is very less. It is in less than 1 second. So they're having a problems while injecting at the kiln riser also. So the only option is about firing at the main burner. We have proposed this type of layout at the plant where the material is coming from the truck tippler, and then it is being shredded to less than 5 mm. And then this is being, after that, we have considered a chlorine sorting system by using IR system, such that there will be any high chloride material which is there that can be separated in the belt conveyor itself before. After that, then it is being passed to the feeding system to the main burner. This is about the coal system and as well as screw feeder, and we have given an ideal rotary valve, and through main burner it can be used. We have done the impacts assessments about the operation and as well as environmental and clinker quality. So we have seen about there is a loss of around 25 TPD of loss clinker production due to high moisture and as well as due to some build-ups and as well as high ash, if any. And as well as the possibility is there change of preheater fan is required also, and as well as maintain optimum oxygen at the back end, and as well as improved quality of AF is also required. And we have seen about the specific heat increase of 5 kilocalorie per kg clinker due to high excess moisture, and this also reduces the flame temperatures. And we have seen about the flame temperature drop around 30 degrees centigrade, because we have to inject at the main burner, and as well as it is a high particle in size. So the flame will go in the length, and as well as due to moisture, the flame temperature reduces. So it comes to around 90 to 100 degrees centigrade drop here. And we have seen the high chloride in this plant where they are getting around maximum of 0.7. If they are going for maximum of 0.7, without the bypass, they can go up to 10% ESR. Of course, by using bypass, we can go further, but we have considered about 5% bypass. It is around, so they can go for 25% ESR in this plant. So at 10% ESR, they can operate around the chlorine within a limit of 0.023. Of course, it's operation, no problems. But however, at 25% ESR, this is going more than normal limits of 300 grams per ton of clinker. So this has to go for having a bypass system of around 5%. So my conclusion is that RDF is utilization in kiln made burner is necessity and stringent fuel quality parameters. And of course, this plant has to require modification in the cooler and replacement of kiln outlet cell and installation of channel burner. And as well as you have seen the chlorate content which is there in the raw materials. And of course, we can't change the raw materials. However, the fuel which is being injected in the plant, they can be reduce the chlorine input through sorting methods, such that the chlorine input can be reduced and bypass can be also be reduced. Because in future, most of the plants, if you want to go for higher chlorine percentage, the plant has to set up a bypass, and of course the bypass material which we have to be dumped, where we have to dump. So before going to having a bypass, try to reduce the chlorine content as much as possible. Yeah. Thank you all.
Thank you, Mr. Reddy. Now we move to the 8th presentation, LC3 clay mapping and their selection criteria in Indian scenario. This presentation by Astha Singh from Indian Institute of Technology, Delhi.
Good evening, everyone. Thank you for sticking to till the last presentation of the day. I will be presenting on the LC3 clay mapping and selection criteria in the Indian scenario. So we all know that we have came across the limestone calcine clay cement. It is the combination of the clinker, calcine clay, limestone, and gypsum. And when we look into the synergistic reaction of the calcine clay, clinker, and limestone with each other, so calcine clay is the major component that plays the role in the strength development and other properties for the LC3 cement. So today I will be talking majorly about how we can identify the clay suitable for the LC3 production. So according to this data, this is the global distribution of clay minerals, which shows different clay minerals all over the world. Here we can see in the in India especially, we can see that the kaolinite presence is very less if we look at through the global distribution of clay minerals, and smectite is present in a large quantity in comparison to kaolinite. But this distribution basically shows the kaolin clay, which is of high purity kaolinite content, which is more than 80%, greater than 80%. But for the LC3 production, we are not looking for the clays of high purity kaolinite content. We are looking in the specific range between the 40 to 60%, which is actually the waste material from the cement industry and the ceramic and paper industries. So we have done the clay mapping all over the India. There are still some regions left, but as of now, we have collected this data. Here, green triangle shows the cement plants in the all over the India, and the red one shows the presence of the kaolinitic clays. And in the region of Gujarat and Rajasthan, we have found the clays of the purity between 40 to 90% kaolinite content. In the Meghalaya region, we have seen the purity of 60 to 80%. In the regions of Andhra Pradesh, Telangana, we have seen 40 to 60% purity of clay, and in the Tamil Nadu region, we have seen 40 to 80% of kaolinitic clays. So basically, we are talking about the clays that are suitable. The data that we have for the kaolin clays are very limited. Basically, kaolinitic clays is very limited because we have been focusing so far on the kaolin clays, which is suitable for cement companies. But for the LC3, we are not looking for that. So there is a need to identify such clays, such mines, which has the low purity of kaolinite with the presence of impurities like quartz, muscovite, and so on. So we have set the selection criteria for the clays. For the first stage of the study, we look at the XRF data, and the first things that we look into the selection criteria is the alumina content. Alumina content, I have taken 2 clays as a demonstration, clay A and clay B. The alumina content is 13%, and for clay B it's 33%. And the LOI for the clay A is 4%, and for clay B is 13%. So for the selection criteria, we generally take 3 parameters. Firstly, it's alumina to silica ratio, then LOI content, and the LOI and the alumina content. So for the threshold value of 40% kaolinite content, the alumina should be greater than 15.8%, LOI should be greater than 5.6%, and alumina to silica ratio should be greater than equal to 0.2%. So when we look at the clay A, we can see here that alumina to silica ratio is below 0.2. Similarly, LOI and alumina content is below the threshold limit that we have kept for the selection criteria. Whereas when we look at the clay B, these criteria are these criteria are fulfilled. So we can say here that the clay A is failed, and clay B, we can move ahead. We can move ahead with the clay B for the further analysis. So this selection criteria actually comes handy when there are numerous clays that when we go to a cement, when we go to mines and we collect several clay samples. For example, we collect 10 to 15 clay samples, and XRF is easily available in the cement plants. So this is the first study that we should do, and we should look into these 3 parameters as the stage 1. And if even one of this parameter is not fulfilling, we should not go ahead with the clays. At the stage 2, for the confirmation that the clay is of the quality that we are looking for, we do the TGA analysis, thermogravimetric analysis. We look at the decomposition of the clay. So the kaolinitic clay has a typical decomposition range between roughly between 400 to 600 degrees Celsius, and we calculated through the DTG curve, and through the mass loss we calculate the exact kaolinite content present in the clay. And also we do the X-ray diffraction to identify the different minerals other than kaolinitic clays. Now, after we have selected the clays, we do the calcination as per our availability of the kiln, rotary, flash calciner, or muffle furnace. And then we do the quality check for the clays. We can see here in the XRD graph that in the raw clay, we can clearly see the kaolinitic peak. But after the calcination, that kaolinitic peak is not visible. This indicates that the proper calcination of the clay is done. We also have to take into care that there is no spinel or mullite or cristobalite formation to ensure that there is no over-calcination of the clays. Second quality check is done by TGA graph. TGA. So in the raw clay, we can clearly see here that there is a clear mass loss between around 400 to 600 degrees Celsius. But in the calcined clay, we cannot see the mass loss. And this indicates that the calcination is done properly and there is no kaolinite left in the system. At the end, before preparing the LC3 blend, we do the lime reactivity test for a clay. And we do it according to IS 1727. So first we calculate we determine the specific gravity of the clay, and we optimize the flow water using the flow table, and then we do the lime reactivity. And we have, after a lot of trials, we have kept the minimum LR value to be 8 MPa for qualifying the clay for further use in it for the limestone calcined clay cement. Thank you.
Thank you. Thank you, Asta Singh. Excellent presentation. Is very important that LC3 is the very key product which required for the country to develop and produce in a larger scale. We move to the last paper. Is on AFR optimization in terms of cement pyroprocessing. Mr. Kailash Singh and also Mr. Pratik Sharma.
Good evening, everyone, respected chairman and co-chairman, all the delegates and ladies and gentlemen. I am Kani Singh from JK Lakshmi Cement, and along with me, we have Mr. Pratik Sharma from team NCCBM. We all know that the calciner outlet temperature and CO plays a very vital role in the kiln stability, and every shot of help to stabilize these two parameters definitely help us in our continuous optimization of the kiln. Along with that, it also facilitates us to go for the maximum uses of the AFR. So based on these parameters, keeping these two important parameters in our mind, we at JK Lakshmi Cement decided to go for joining hands with NCCBM so that we will be coming up a unique idea that will be ultimately helping us in improving our AFR usage as our JKLC Sirohi plant. And based on that only, we decided to go with the technology supplier, Mrs. Livensense, and with the help of NCCBM and Livensense, we have come up with a unique solution that is AI-based model, which will be ultimately helping us to improve our liquid AFR usage at present. And in the coming future, we will be using this same model to go for the maximum usage of the AFR in terms of solid AFR, which will ultimately help us to improve our TSR level. So the scope of our work, which we have collaborated with Livensense and NCCBM, that is the forecast of the average temperature of both the bottom cyclone, cyclone 6. That is basically the, based on this temperature only, the pre-calciner coal values gets modified. And apart from that, we are going to forecast the CO level of the bottom two cyclones average CO level. And outcomes will be ultimately increasing in the liquid AFR percentage by 20 to 25%. And we have divided this forecasting in two steps. The first will be based on the forecasting of the average temperature of cyclone 6 and average CO of those cyclones. And based on that, in the step 2, we are going to increase the liquid AFR level, and along with that, if there is any possibility to reduce the CO cold TPS so that ultimately the forecasted temperature will be met. And we very well know that, especially in case of liquid AFR, we don't have that much of quality parameters, and even we are getting the liquid AFR from the same source, the quality differs at every moment. So that is the first challenge, and apart from that, not only the cyclone 6 temperature or CO that ultimately stabilizes our kiln operation, there are various parameters also. Now, if we talk about the model, that how our model is collecting the data and how it is predicting that what will be the forecasted temperature in the CO. So based on that, we have collected past 4 months data. Every 1 minute average process data we have collected. The raw material data, which we generally in the kiln operation, we collect in every 2 hours. And every day coal values, the coal data we have collected, and based on that, our model has been developed. So what we are doing, we have aligned all this data on 5 minutes data interval. And the forecast of the cyclone 6 temperature, the model accuracy is around 85%. And in the CO forecasting, the model accuracy is around 80%. So the next step is the recommendation of the increase in the liquid AFR percentage. And lastly, we are going to validate through our kiln operation. And within a month, we are going to utilize this AI-based model in our kiln at Sirohi. Now for further details, I would request Mr. Pratik Sharma to take you ahead.
Thank you, Ganesh. So further, the most important and critical thing, the process parameters which we have to consider for the model. Can you have the presentation? Yeah. So first of all, what is the critical parameters which we have to consider for the process parameters? So there are n number of parameters available in the preheater, kiln, and calciner. So we go through all the parameters and we see the correlation. What are the strong correlations we have? So more than 0.6 to 0.7, the correlation we are having with this cyclone 6 average temperature are the main cold TPH, kiln feed, preheater fan RPM, kiln speed. This kilocalorie per kg is the heat, CV of the fuel. Kiln inlet temperature, PC coal, liquid AFR flow rate, PC outlet draft, kiln inlet draft, preheater fan power. Some parameters we can see logically they are linked, but some are such that they are indirectly or they may not be linked, you cannot correlate. But still we have to consider them because they are strongly correlated. So those all parameters we put into the model, and then this is the prediction. You can see actual versus forecast. It is very close, and the accuracy of the model is around 85% in this case. That means 85% times it is within the prediction is within the actual values. Then further, this is based on the past 3 months data. Then we further collected 2 months data, and our model further improved by 2 to 3%. And we again relearned the forecasting models. Earlier we used only linear models, but the accuracy was only 40 to 50% in the starting. Then we further used the non-linear models in this, and then the accuracy improved to more than 80%. Then out of total data, 80% of data we use for the test data, for the train data, and rest we use for the test data for 4 days runs. Then also we tried to have some recommendation engine in this. Not only the prediction. First, the phase 1 is the prediction. If you are able to predict the conditions after 5 minutes, what is happening, it will help the CCR operator. He will came to know what is going to, temperature is, CO and the temperature of cyclone 6. It is going to increase or decrease after 5 minutes. So he can take the action accordingly. This is a part of phase 1. So, but apart from that, if you see the forecasting next 5 minutes temperature, then it will check whether temperature is more than 900 or not. This 900 figure we have we come with the discussions of after the plant because they said that till 900 the plant operation is stable and there's no issue. So we try to have this temperature within the limits. So if it is less than 900 degrees Celsius, then it's okay, and TSR will be AFR and coal is okay. Otherwise, if it is not there, then other iterations will be done, and till the new values will be recommended for AFR and coal in this case. So in the end, if you see the average coal TPH, by the recommendations, the average coal TPH, which is 8.3 TPH, it will reduce to 6.8 TPH, and the AFR, which is 2 meter cube per hour, will increase to 2.7 meter cube per hour, which is around 21% rise on day average. So this is demo would be arranged with appropriate digital twins, and further we will deploy in the plant at the next month or so. So that's all from my side. Thank you.
Thank you. Thank you to both of you, and I think now we are, I think slightly, we have at least a couple of questions which we can take from the audience.
Hello. Yeah, this is regarding the co-processing of SPL mixed fines. This SPL, is it from aluminum refinery or alumina refinery? Aluminum smelting or alumina refinery?
It's an aluminum smelter. Yeah.
Aluminum smelter, but it was written there alumina refinery.
Red mud and smelting generates SPL.
Yes.
It's smelting.
Yes, aluminum
yes.
smelting. Yes, yes.
SPL is a part of smelting.
Yeah.
Refining generates red mud.
Yes, yes. And what are the values of the toxic elements, what you have mentioned there? What is the values and how did you measure it?
Which value? This leachable cyanide?
Yes, cyanides and all.
And
yes.
soluble. We have tested it in an NABL lab.
What is the method you have used and what is the...
Method, that whatever the method prescribed by the...
Yeah.
What is the technique you have used or do they have used and what are the values?
Values already I have displayed. Against of the 20 ppm, we got 3.5 for the leachable cyanide.
Okay.
And 120 ppm for the soluble fluoride, we got 5.5 ppm. That material has been tested in NABL lab of one of the authorized lab which can do this test. We have not tested this in our lab.
No, that's fine.
I think you can have a discussion with her because the session is anyway will be over.
Note down my number, it is
And
there
just,
in that.
yeah, just one more question.
You can interact with her separately now.
Yeah, just one more question. You have mentioned the alumina and silica content.
Yes,
this
sir.
is the elementary composition and you are going to use it in raw meal. Did you ever try to look at the phase composition? Because that is the phase in which silica and alumina are present. That is going to help you in the grinding, affect your grinding and residue and all these things.
No, you mean to say whether this material has given the grinding, means increasing the residue?
No. You have mentioned this is silica and alumina in the elemental composition. Did you ever try to look at the
elemental oxides? It is a silica and alumina. It is
alumina,
not a silicon.
silica, alumina,
Silica
and what are the
alumina.
phase composition? What are the phases? Did you look at that?
No, we have not tested the phases. We did only the oxide analysis, which is applicable for the cement.
Alkaji,
Yes.
I think you can meet him and explain in detail. I
Fine,
think
sir.
he's having many questions.
Okay.
So since we are
Note
short
down
of
my
time,
number. Thank you.
yeah. Now I request Mr. Shankar Choudhary, Shankar Choudhary to make his comments.
Thank you, Chairman Rao Saab. If I will go to the all presentation is very insight, very meaningful. If I will go that ALCA, that SPL, we have to use all the raw material as well as the AFR alternative, which is available near to plant. Definitely we have to identify and we have to utilize. Regarding Kapilji, that Sujjan, this is very required nowadays because if availability of the material, but you cannot feed on the consistency level, you cannot achieve the TSR. So this is very much required. Regarding Netaji, as he has explained about the liquid feeding system, very much aspiration that is 2040, that is carbon negative, as well as 40% TSR aspiration. This is very good inspiration for all, because nowadays in India, still today morning we have discussing around 6% TSR. But when we are talking about European country, there is 70, 80, even 100%. So this is the role of some plant who is already achieving around 20% TSR. Definitely he has to go for the 40% TSR. Then country average can be achieved as high as possible. Regarding Pankaj Tiwari ji, he has also mentioned that 7% of the liquid ratio in his plant and aspiration of 30% TSR. This is very good insight. Regarding Sarvana, this is a message for clean and green fuel, and it's also started with the 10% TSR and achieving the 16%. But just I am highlighting when we are talking about the TSR, don't mitigate, don't compromise the quality, because I have seen in some slides there is for meeting the clinker requirement, C3S is the 48%. So please don't compromise the quality. There is several options to how to increase the production. Regarding Pankaj Kumar, that is this 2 into 100 KL liquid facility, and he has given in presentation regarding the safety aspects also, because we are handling of such a liquid hazardous waste, the safety aspect is much more required. Regarding KPK Reddy ji, this is a very good information about the case study. This even a small plant can use and achieve 10 to 20% TSR. Generally, when we are talking about TSR, earlier the conceptors, this main plant, which is the biggest plant, it has to work TSR, but this good case study has been given. A small plant, 40-50 TPG, also can use through main burner and can achieve the TSR of 10%, 20%. Definitely it will helpful for which a small plant is running, and you can take the benefit, take the case study from that. Regarding Asta Singh, regarding LC3, he has given very insight and very good information about 40 to 90% kaolinite content available and throughout the pan India. This is a future cement. Definitely, this will be the work, and this is we have to work. And we are waiting. Several plants is waiting to produce the LC3 when BIS code, everything will be finalized. Definitely, we have to do. Regarding my comment, we have to utilize nowadays. Earlier, as DG Mahapatra was asking, I was telling in the morning, this level as the earlier, that was the how TSR, how FR journey can improve. Already this level has been crossed. Now I request to quality person make such raw mix, CCR engineer can demand how he can feed the more TSR. Earlier, when some kiln disturbance, CCR engineer first stopped the CCR and he has improved the kiln performance. But nowadays time has come to make the environment, create such environment. CCR engineer has to demand, make the raw mix like that. Even the kiln disturbed, he has run the solid AFR, liquid AFR, so this can achieve the TSR. So this is the good session, and I think all this presenter having the very good insight, very good presentation he has given, and I think within time we have completed also. Thank you, thanks a lot.
And so thanks to all the presenters who made the presentation, and I think plus minus 1 minute they could stuck to the time, and I think my co-chairman has already briefed all the paper. But what I would like to say is basically we are looking for a net zero story. In that net zero story, the raw material contributes to 540 kgs of CO2, and we have a 275 kgs coming from the fuel. Now, this particular session, which is ultimately talking about what is the vision, how we can actually mitigate this to the fuel part of the CO2, which is that is something being addressed. And I think 3 presenters made about their net zero roadmap, what they mentioned, and then we also have a presentation talking about the safety challenges when you use hazardous liquid fuels. I think the 2 companies made the presentation on the liquid fuel, and there are a lot of learning for the companies which would like to use the liquid waste in the cement kilns. And most important is that we are talking about how to feed the RDF into the main burner. So that's something which is how to bring the size to 50 mm and to 5 mm size and ultimately feed into the kiln. So this is something which requires that what is the type of shredders and what is the type of equipment we are going to install to feed the dry waste through the kiln burner. And if you look into the other part, which is the raw material part where we are getting CO2, and the LC3 is addressing that particular subject of what is the inventory of the calcined clay available and which are the quality, how you are going to select, is it suitable for cement or not. That is something the IIT Delhi presentation is touching upon. Then I found that this is something in this particular session, we have the research institute, NCB, telling about how to design a chute, which is going to feed the material into the kiln and into the calciner, and what are the measures required to be taken after taking the feedback of marine plants. It's very important that how the industry is working with the academic institutes like IIT and also research institutes like NCBM. If we're able to work together, I think the thinking about net zero is not a distant dream. I think definitely Indian cement industry will prove to the world that yes, India will be the first country going to ultimately do a net zero cement in the country using carbon offsets. And I think many ideas I think in the earlier session also we had a presentation about bamboo for the Northeast. Each region in India, we have some sources for the mitigating the fuel CO2 and also for the raw material CO2. So thank you for a patient hearing. I hope this particular session might have definitely added value to all of you. So thank you. And
thank you very much, Rao sir. It is always our pleasure to listen to you. And again, thanks for concluding this session within time, although we started a little bit late. Thank you, Choudhary sir, your remarkable comments for us. I think with your comments, and you have concluded each and every paper with your comment. Thank you very much. So now I request Director General, so please come on dais and give a memento to our chairman and co-chairman, sir. And I request Pratik Sharma, please join the DJ, sir.
It is my honor to give you the mementos. And you are the highest using TSR plan. Yes, 55%. 25%.
Pratik. Sir, Choudhary sir is also, he is connected with NCB since long. He is from NCB, student also. Yeah.